So electrochemical cell. Electrochemical cell. This is a chemical device, or is a chemical cell. It's a chemical device or cell which converts chemical energy. It converts chemical energy to electrical energy. Chemical energy to electrical energy. So in electrochemical cell, chemical effects brings about production of currents, production of EMF, of currents. While in electrolytic cell, current effect brings about chemical decomposition. So if you want to state the differences between electrolytic cell and electrochemical cell, so the difference between electrolytic cell and electrochemical cell is that in electrochemical cell, in electrolytic cell, current effect brings about chemical decomposition. Why in electrochemical cell, chemical effects brings about production of currents, That's the major difference. You have electrode as well. You have the cathode, you have the anode. You have the container, you have the electrolyte as well. You have the electrolytes, you have the cathode, you have the container, you have the electrodes. Then here you have your voltmeter here. Here there will be production of current, but unlike the one where the current will be used to decompose the electrolyte. But here we are measuring, this one is producing current. So this is the diagram of electrochemical cell. So examples of an electrochemical cell. One, we have Daniel cell. We are coming to that. Daniel cell. We have Leclanche cell, or simply dry cell. dry cell, electrolyte cell. Then we have lead acid accumulator, which is a secondary cell. We have alkaline nickel ion or cadmium cell. Alkaline nickel ion. These are some of the examples of electrochemical cell we have. We are not into this for now. We want to see electrolysis. Terms used in electrolysis. What are the terms used in electrolysis? Terms used in electrolysis. We have one. We talk of electrolytes. Electrolytes. Definition. Electrolytes. Electrolyte is a compound, is a substance. It's a substance, usually a compound in molten form, molten or aqueous form, in solution form, which allow passage of electricity. It allows passage of electricity and decomposes in it, meaning it ionizes it and decomposes in it. That's the definition of an electrolyte. So that's the definition of an electrolyte. So e.g., we talk of sodium chloride solution. If you pass current through sodium chloride solution, you have sodium chloride like this, which will decompose into ionize to sodium ion plus chloride ion. That's what we mean by decomposition. If you use A2SO4 as an electrolyte and you pass current through it, we have 2 hydrogen ion plus SO4 2 minus. That is ionization. So that is a electrolyte. So we have types of electrolytes. Types of electrolytes. Types of electrolytes. In chemistry, in physics, types of electrolytes. We have one. Let me call it A. We have strong electrolytes and weak electrolytes. So let's see strong electrolyte first. Strong electrolyte. A strong electrolyte is an electrolyte that can ionize completely, totally in solution. That can ionize completely in solution. We call it a strong electrolyte. So examples of strong electrolytes. We have one. We have dilute acids, both mineral and organic acid, but organic acid are generally weak electrolyte. So let's say dilute mineral acid. E.g., we talk of dilute A2SO4, we talk of ACl, we talk of HNO3, you talk of HBr, HF, etc. etc. All these are strong. 2. We talk of alkali, e.g. the one that are strong, that is strong base, sodium hydroxide and potassium hydroxide, they are strong as well. 3. We talk of soluble ionic salts, we talk of soluble salts, e.g. talk of potassium chloride, we talk of sodium chloride, we talk of copper 2 sulfate, etc. We have sodium ethanate, Ca3COOONA. We call it, this one is known as sodium ethanate. Take note of that. We call it sodium ethanate. Sodium ethanate and etc. All these are strong electrolyte because they can ionize completely in solution. Look at what they mean by that. If you have sodium chloride, aqueous, it will be sodium ion plus chloride ion. You have A2SO4, it ionize completely to 2 hydrogen ion plus SO4 2 minus and etc. So we are giving examples of strong electrolytes. Weak electrolytes. Weak electrolytes. A weak electrolyte is an electrolyte that can ionize or that can ionize partially in solution. This one will only ionize partially in solution. E.g. examples. Let's see examples. We have weak acids. Weak acids are weak electrolytes. We talk of A2CO3. We talk of ethanoic acid. The one we call acetic acid. All these are weak acid. Lactic acid. And let me just generalize all organic acids, etc. They are weak acids and they are weak electrolyte. Talk of lactic acid. Under organic acid, you can talk of lactic acid, lime juice, that is citric acid. You can say citric acid, acetic acid, that is ethanoic acid. You can talk of ethanoic acid. You have ascorbic acid, and etc. All organic acids, they are weak acids. That is a very good example. Even water is a weak electrolyte. Is classified under weak electrolyte. 3. We talk of that is weak electrolyte. We talk of ammonium hydroxide, or simply aqueous ammonia. I'm giving you the common one they normally use in past questions. So ammonium hydroxide or aqueous ammonia will fall under weak electrolyte, and etc. 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 So let's see ionization of what do they mean. Like A2CO3 is a weak acid. It has 2 atoms of hydrogen here. But when it ionizes, it only releases 1 hydrogen ion. Then you have it is, instead of releasing the 2, because it is weak. That is ionization. Likewise, the same thing as Ca3COOH. How many hydrogen atoms? 4. We ionize to Ca3COO minus plus hydrogen ion. This is a ethanate ion. This is ethanate ion plus hydrogen ion. So you can only release 1 before it is very, very weak. So it ionizes partially in solution. Take note of this and take note of this. This is what we are saying by weak electrolytes.